All right, we are back. Hello once again, stream. We are here still at my girlfriend's place. We'll be heading back to the normal setup tomorrow, where we'll get into our normal setup and streaming environment. But today we are going to be continuing on with chapter 5. Let's get the Twitch started up. There we go. All right, today we're going to be continuing on with chapter 5 in Pro Git. Today is Saturday, April 12th, 2025. Feeling good, feeling great. Sorry I am late today. It's going to be a later stream than normal. I was just enjoying my Saturday. It was 75 degrees, no clouds, so I was outside pretty much all day today, walking around. Went on a couple of parks with my dog and threw the ball with her a lot, and really just kind of had a day to enjoy the weather and just get into everything. Hey, Luis 21, how's it going? Welcome back in. I hope you're doing well. Thank you so much for joining me again. Hopefully the stream doesn't lag too bad here. I think it'll be okay. All right, let's go ahead and get the chat loaded up. So you guys aren't aware, yesterday I did a after hours stream into from like it was honestly from like 11 to 2 in the morning. Um, right, so I streamed last night from like 11 to like 2 a.m. for a after hours coding session on the Small Business Manager. I'll quickly show you guys that here in a second, what we were able to complete yesterday. Chapter 5 today in Pro Git is going to be pretty easy. It's not going to be too hard. But I am going to move this off of my headphones just because the quality of the audio is really bad. Okay, I'll leave that how it is. And then we'll come here, we'll go advanced, and we'll turn this up a little bit. There we go. All right. Yeah, so yesterday we did a coding session on the Small Business Manager. And so what we were able to accomplish yesterday was we were able to get the balance sheet done. So the balance sheet will appropriately sum up the unsold inventory for the given calendar year that you're currently inputting items under. Right, so we wrote limitations to our date checks to not allow for dates in the future year. So you have to input items and expenses and transactions within the current year. You can do past dates up to that current year. So I can load in an item from like January in case I forgot it, but I can't go back into 2024. So once the year is done, it's done. So you just have to make sure to get all your transactions in so that you know, they handle okay. But so now we have the balance sheet being appropriately summed for unsold inventory in 2025 while all items are sold, so the balance sheet is zero for remaining assets. But if I go ahead and add an additional item here, 2025-04-12 test size large cost 10, if I add that item in, go to my balance sheet, there you go. You can see that that unsold inventory is being summed here with under that calendar year for the balance sheet. So at this point in time, the program is pretty like it's pretty done like in terms of like the general functionality required to actually get these statistics reported. And so what I'm going to do is over this next week to finalize the program, we're going to convert this size option into a combo box. And then we're going to allow in the settings menu for the user to not only update the name of the business here, but also update the additional, right, update whatever sizes they prefer for their business to track. They can also import their own categories and methods for their expenses, and then they could also import their own sales platforms and potential transportation methods for their individual transactions. So in the settings menu, they'll have a little bit more customization for these individual tracking methods, but the overarching principle of the project and how the math is handled via across these different tabs is pretty much done. So we might have some bugs here and there to work out that we can find just through testing and practice and trial and error. But like I said, is I think it's pretty straightforward in that it is kind of it's complete. And so yesterday we fixed that bug last night also of the cost of goods sold not appropriately being added, right? So if you bought an item, returned an item, and then if you sold an item, returned an item, and then sold it again, well, you have two instances of the sale, but only one was being recorded because it was just getting that singular item ID from the transactions. But as you can see, the item number one was sold in two instances. So we have to account for that within our cost of goods sold. So rather than, we just created an overarching loop and did some joins across these two transactions and income statement, or the transactions and the inventory in order to, we did some joins to get those data points of each income statement or each transaction line, right? So by joining the inventory and the transactions together via SQL query, we're able to get each price of the item for every row, basically, rather than just individual, kind of like a set of item IDs that was being handled originally. Now we're going by actual rows, so we're appropriately getting all the information for every transaction, including multiple sales and returns for the same item. So now we have $30 for cost of goods sold here. As you guys can see, we have three items that are sold in 2025 that are summing up to 30. So, but that item number one here was sold twice. We're not going to count it twice. Well, we are, but the first one is offset by this return, and then we count the cost of goods sold again here. So we sold it for 10, right, the cost of goods sold went up by $10 here on the transaction for number one. It was returned, so the cost of goods sold went back down to 0, and then it was sold again, so then it went back up to 10. So we had to account for each of these transactions as individual line items via their row, right, rather than just accounting for the item ID and then like not accounting for, multiple transactions across that item. So we were able to solve that yesterday as well. And so now it's working pretty nice. Let me pull up the chat here. I get the chat on my phone. Da, 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 da. There we go. All right. Cool. Let's go ahead and so that's the program so far. It's really, really cool. And so, yeah, I think it's awesome. So I'll go ahead and we're going to finalize this. Oh, I didn't get the chat on the stream yet. The Twitch is lagging me though here. I might have to stop the Twitch. Oops. Yeah, I'm gonna go ahead and stop the Twitch. It's just too inconsistent, bopping up and down. Or it might be okay. It's fluctuating. I have it at 11,000. Yeah, we're gonna have to stop the Twitch. All right, Twitch, I'm sorry, you guys. If you guys are on Twitch, I apologize. I just don't have the Wi-Fi power at my girlfriend's to be able to run the multi-stream. I have enough power at my apartment. I have a fast enough internet to allow for it, but yeah, it's just not working out here, unfortunately. But I'll keep going on YouTube. So if you're on Twitch, come over to YouTube, Michael Dems on YouTube, to go ahead and continue on here. All right, stop the stream there for the Twitch. Let's go ahead and just crank this up to like 15. Okay. All right. Let's just get on with this. All right, you guys. So today we're going to be jumping back into ProGit. So I'm super excited to be jumping back into chapter 5 here. Should be really good. It's not going to be too long, honestly. I think it'll only take us about a half hour to read through this, chapter 5, which is really cool. And so, yeah, let's get right on into this. Thank you guys so much for being here. Let me know what you guys are studying and working on. If you guys are in school and are in finals week, let me know how your finals are going. I really appreciate you guys all for being here. Let's move like we had yesterday, I guess. Let's do this guy over here. And then we'll zoom in here. Bring this guy just over slightly. No, I'll bring this back. Let's get this set up. We'll be back at our normal setup tomorrow, guys, so bear with me here. Thank you so much for your understanding. How does that look? Let's see. That's fine. Yeah, for some reason, the camera lag is that's what's causing that the internet gets hit by my camera. It seems like that's how I can kind of start to tell I'm lagging. All right, we are on chapter 5, you guys. Chapter 4 was pretty dense. Um, Honestly, you guys, I didn't have the greatest notes throughout chapter 4. As you can see, there's some sections that are pretty blank. Um, they had a lot of information about setting up Git on your own personal servers and like if you were going to interact with um, Git on like a company server or things like that. So it's useful information that we'll definitely want to revisit in the future when we have experiences like if we get a job and as a developer and have to use a company workflow and server and stuff like that, then definitely we'll need to revisit that chapter and take a look at it again. But for our purposes right now, it's really not that actually influential as we aren't really dealing with server stuff as we have GitHub host our current work as a server. So right, that's kind of the new typical things. But I for sure am interested in like I talked about yesterday, maybe getting work doing and building a home lab on the stream where we'll go ahead and develop and set up like a home server within my apartment where people that can join my network and people that are on my network can get access to the server file system and database and get access to like a media library of like pictures or whatnot and then we could have some password protected directories for like sensitive pictures or things like that more that we don't want public, but if anyone could join the network and then they could get access to like a media library to watch movies or shows or things like that that I have accumulated over time or something. I think that would be really really cool to get into and build on the channel. What do you guys think? Um, no pro gamers in that household. Sad to see. Yeah, there's definitely no gaming going on over here. Just a little bit, just some Netflix girls. All right, let's go ahead and get into this. All right, chapter 5, you guys. This marks halfway done with the book after today. There's 10 chapters in the book. And so we're really moving through 10 quick days. We'll have a whole book on computer science and Git workflows completely done. Yes, we'll need to get some additional practice and, work with Git, but we're getting this surface level information now so it can be prepared for it later on. Okay, 5.1 distributed Git. Distributed workflows. Now that you have a remote Git repository, set up a focal point for all the developers to share their code. And you're familiar now that you have a remote set up as a focal point for all the developers to share their code, and you're familiar with basic Git commands in a local workflow, you'll look at how to utilize some of the distributed workflows that Git affords you. In this chapter, you'll see how to work with Git in a distributed environment as a contributor and an integrator. That is, you'll learn how to contribute code successfully to a project and make it as easy on you and the project maintainer as possible, and also how to maintain a project successfully with a number of developers contributing, right? So this is going to be really good information, especially if we're going to be hosting our small business manager and allowing for people to submit pull requests for fixing things and adding features. Distributed workflows. In contrast with centralized version control systems, and the distributed nature of Git allows you to be far more flexible in how developers collaborate on projects. In centralized systems, every developer is a node working more or less equally with a central hub. In Git, however, every developer is potentially both a node and a hub. That is, every developer can both contribute code to other repositories and make a public repository on which others can base their work and which they can contribute to. This presents a vast range of workflow possibilities for your project and or your team. So we'll cover a few common paradigms that take advantage of this flexibility. We'll go over the strengths and possible weaknesses of uh, each design, and you can choose a single one to use, or you can mix and match features from each. Centralized workflow, right? In centralized systems, there is generally a single collaboration model, the centralized workflow. One central hub or repository. In centralized systems, there is generally a single collaboration model, the centralized workflow. One central hub or repository can accept code and everyone synchronizes their work with it. Um, a number of developers are nodes, consumers of that hub, and synchronized with the centralized location. So you have a shared repository. All the developers are pushing and pulling from that shared repository. This means that if two developers clone from the hub and both make changes, the first developer to push their changes back up can do so with no problems. The second developer must merge in the first one's work before pushing changes up so as not to overwrite the first developer's changes. This concept is as true in Git as it is in Subversion or any CVCSs. And this model works perfectly well in Git. If you are already okay, so centralized workflow. Define a centralized workflow in Git. A version control strategy where all developers push and pull from a single central repository, usually hosted on a remote platform. Right, all developers push and pull from a single centralized repository, usually hosted on a remote platform like GitHub, GitLab, or Bitbucket. Okay. If you're already comfortable with a centralized workflow in your company or team, you can easily continue using that workflow with Git. Simply set up a single repository and give everyone on the team push access. Git won't let users override each other. Say John and Jessica both start working at the same time. John finishes his change and pushes it to the server. Then Jessica tries to push her changes, but the server rejects them. She is told that she's trying to push non-fast forward changes and that she won't be able to do so until she fetches and merges. This workflow is attractively attractive to a lot of people because it's a paradigm that many are familiar and comfortable with. This is also not limited to small teams. With Git branching model, it's possible for hundreds of developers to successfully work on a single project through dozens of branches simultaneously. Integration manager workflow. Because Git allows you to have multiple remote repositories, it's possible to have a workflow where each developer has write access to their own public repository and read access to everyone else's. This scenario often includes a um, canonical repository that represents the official project, the contributions to that project. You create your own public clone of that project and push your changes to it. Then you can send a request to the maintainer of the main project to pull in your changes. Okay, so basically you have a main repository you clone from, you push changes onto your clone, and then you submit merges of your clone into the main repository. Then you can send a request to the maintainer of the main project to pull your changes. The maintainer can then add your repository as a remote, test your changes locally, merge them into their branch, and push back to their repository. The process works as follows. The project maintainer pushes to their public repository A contributor clones that repository, makes changes. The contributor pushes their own public copy. The contributor sends the maintainer an email asking them to pull the changes. The maintainer adds the contributor's repository as a remote and merges locally. The maintainer pushes merge changes to the main repository. This is a very common workflow with hub-based tools like GitHub or GitLab, where it's easy to fork a project and push your changes into your fork for everyone else to see. One of the main advantages of this approach is that you can continue to work and the maintainer of the main repository can pull in your changes at any time. Contributors don't have to wait for the project to incorporate their changes. Each party can work at their own pace. Dictator and lieutenant's workflow.
Bless you.
Allergies. You guys getting hit with the allergies lately? The LEIEUTENANTS workflows. Okay. This is a variant of multiple repository workflows. It's generally used by huge projects with hundreds of collaborators. One famous example is the Linux kernel. Various integration managers are in charge of certain parts of the repository. They're called lieutenants. So we'll go LIEUTENANTS, lieutenants, right? These are individual integration managers. Integration managers that are in charge of a certain aspect or feature of the overall project. All lieutenants have one integration manager known as the benevolent dictator. The benevolent dictator pushes from their directory to a reference repository from which all the collaborators need to pull. The process works like this. See the benevolent dictator workflow. Regular developers work on their topic branch and rebase their work on top of master. The master branch is that of the reference repository to which the dictator pushes. Lieutenants merge the developer's topic branches into their master branch. The dictator merges the lieutenant's master branches into the dictator's master branch. Finally, the dictator pushes that master branch to the reference repository so that all other developers can rebase on it. Okay. Then you have the benevolent dictator. Right. Give me a def of the benevolent. A central leader or maintainer of a project has a final say. Central leader or maintainer of a project. Who, right, merges the LIEUTENANTS master branches into their master branch and updates the reference repository. Nice. You're describing a hierarchical model often used in large open source projects like the Linux kernel. Here's a cleanup version. Trusted contributors who manage specific subsystems or features of the project. They act as integration managers and responsibilities. I like that a lot better than mine. Okay, and then the benevolent dictator, the central project leader or maintainer who oversees the entire project. They merge the lieutenant's master branch with their main project. We'll take that. Cool. Let's go ahead and make these bolded. Okay, let's keep moving. This kind of workflow isn't common, but it can be useful in very big projects or in highly hierarchical environments. It allows the project leader, the dictator, to delegate much of the work and collect large subsets of code at multiple points before integrating them. Patterns for managing source code branches. Note, Martin Fowler has made a guide, Patterns for Managing Source Code Branches. This guide covers all the common Git workflows and explains how/when to use them. There's also a section comparing high and low integration frequencies. Workflow summaries. These are some commonly used workflows that are possible with a distributed system like Git, but you can see that many variations are possible to suit your particular real-world workflow. Now that you can hopefully determine which workflow combinations may work for you, we'll cover some more specific examples on how to accomplish the main roles that make up the different flows. In the next section, how you'll learn about a few common patterns for contributing to a project. All right. Sweet. Who wants to be number 1670? We're at 1669. Who wants to be lucky number 1670 out there? Thank you guys so much for joining me here. My name is Michael. I have a degree in human biology and a minor in chemistry. I've been teaching myself how to code for about 10 months now after my 9 to 5 job as a formulation chemist. I have been working as a formulation chemist for about 3 years since I graduated college, a little over 3 years since I graduated college in 2021, end of 2021, beginning of 2022. And I'm currently a scientist 2 formulation chemist where I make biological controls that are used in patient diagnostics and research and development and hospitals and very other settings and stuff. So thank you guys so much for being here and joining me. We're currently reading Pro Git. We have been reading every day for the past a chapter a day for the past 5 days. We're currently on chapter 5, and we have 10 chapters, so we'll be done here in just a few more days. All right, so 5.2, distributed Git contributing to a project. The main difficulty with describing how to contribute to a project are the numerous variations on how to do that. Because Git is very flexible, people can do work together in many ways, and it's problematic to describe how you should contribute. Every project is a bit different. Some of the variables involved are active contributor count, chosen workflow, your commit access, and possibly the external contribution method. The first variable is active contributor count. How many users are actively contributing code to this project and how often? In many instances, you'll have 2 or 3 developers with a few commits a day, or possibly less for somewhat dormant projects. For larger companies or projects, the number of developers could be in the thousands, with hundreds of thousands of commits coming in each day. This is important because with more and more developers, you can run into more issues making sure your code applies cleanly or can be easily merged. Changes you submit may be rendered obsolete or severely broken by work that is merged in while you were working or while your changes were waiting to be approved or applied. How can you keep your code consistently up to date and your commits valid? The next variable in the workflow is the workflow in use for the project. It is centralized with each developer having equal right access to the mainline code. Or is it centralized with each developer having mainline access to the main code line? Does the project have a maintainer or integration manager who checks all the patches? Are the patches peer reviewed or approved? Are you involved in that process? Is a lieutenant system in place? And do you have to submit your work to them first? The next variable is your commit access. The workflow required in order to contribute to a project is much different if you have write access to the project than if you don't. If you don't have write access, how does the project prefer to accept contributed work? Does it even have a policy? How much work are you contributing at a time? How often do you contribute? All these questions can affect how you contribute effectively to a project and what workflows are preferred or available to you. We'll cover aspects of each of these in a series of use cases. Moving from simple to more complex, you should be able to construct the specific workflows you need in practice from these examples. Commit guidelines. Before we start looking at the specific use cases, here's a quick note about commit messages. Okay, so here we go. Let's do commit guidelines. Um, Having a good guideline for creating commits and sticking to it is what makes working with Git and collaborating with others a lot easier. The Git project provides documentation that lays out a number of good tips for creating commits from which to submit patches. You can read the Git source code in the documentation/submitting patches file. First, your submission should not contain any white space errors. Git provides an easy way to check for this. Before you commit, run git diff dash dash check, which identifies possible white space errors and lists them for you. So what are white space errors in Git? White space errors include related to unnecessary or inconsistent spacing in your code. This can happen when you mix tabs or spaces indentation. You have trailing spaces at the end of a line. You leave blank lines with one space. You accidentally add white space or changes that don't affect the logic. Why it matters. It clutters diff with meaningless changes. Okay, so we'll say check and remove white space errors. What are you doing? What are you doing?
Gaga's Coachella set.
Before committing. So white space errors, additional spaces or tabs or lines, blank lines that clutter the Git diff. So we'll do git diff dash dash check. Check and remove white space errors. So we'll go like this. We'll just put white space errors. And then we'll do this. Like that. Additional white spaces. Cool. Let's zoom in here a little bit on this guy. Okay. Output of git diff check. If you run that command before committing, you can tell if you're about to commit whitespace issues that may annoy other developers. Next, try to make each commit a logically separate change set. If you can, try to make your changes digestible. Don't code for a whole weekend on 5 different issues and then submit them all at once. Massive commit on Monday. Even if you don't commit during the weekend, use the staging area on Monday to split your work into at least one commit per issue with a useful message per commit. If some of the changes modify the same file, try to use git add dash dash patch to partially stage files covered in detailed in interactive staging. The project snapshot at the tip of the branch is identical whether you do one commit or 5 as long as all the changes are added at some point. So try to make things easier on your fellow developers when they have to review your changes. This approach also makes it easier to pull out or revert one of the change sets if you need it later. Reviewing history describes a number of useful Git tricks to rewriting history and interactively staging files. Use the tools to help craft a clean and understandable history before sending the work to someone else. Okay, so we'll say commit often, right? So we'll say commit separate, commit logically separate change sets. So commit changes that commit changes we'll say give me a general def for commit logically change set. Hey Wing Hong, how's it going? Welcome in. Welcome back, my friend. Welcome in. Sorry I didn't say hello to all the others. Tim, Mahan, Luis, thank you guys so much for joining me again and continue on with Git here. A logically separate change set means grouping related changes into a single commit and keeping unrelated changes in separate commits. Each commit should represent one clear purpose or idea. Right? I like that. Do that. Let's put that here as well. Let's put this here too. Oh no, up there. Okay. And then we'll say for here, right, this will be git add dash dash patch. This will partially stage files if some of the changes modify the same file for different. What does the git add dash dash patch do then? Git add dash dash patch or git add dash p lets you interactively choose chunks, aka hunks, of changes to commit instead of adding the entire file. Okay. Choose chunks of the file to commit, add to the staging area commit rather than the entire file. Let's see if it likes that. That's a good solid summary. Related group changes, single commit. Use this particular stage changer when multiple changes exist in the same file but belong to different commits. Take that. There we go. Cool. This approach also makes it easier to pull out or revert when a change. Okay, got you. The last thing to keep in mind is the commit message. Okay, what's the commit message? Getting the habit of creating quality commit messages makes using collaborating with Git a lot easier. As a general rule, your message should start with a single line that's no more than about 50 characters, and that describes the change set concisely, followed by a blank line, followed by a more detailed explanation. Include your motivation for the change and contrast its implementation with previous behavior. This is a good guideline to follow. Write your commit message in the imperative, quote, fix bug and not fixed bug or fixes bug. Here's a template you can follow, originally written by Tim Pope. Okay, so capitalized, short, 50 chart summary. More detailed explanation if necessary. Wrap it about 70 characters or so. In some contexts, the first line is treated as the subject of an email, and the rest of the text of the body. The blank line separating the summary from the body is critical unless you omit the body entirely. Tools like rebase will confuse you if you run the two together. Write your commit messages in the imperative fixed bug and not fixed bug or fixes bug. This convention matches up with the commit messages generated. But commands like git merge and git revert. By commands git merge and git revert. Further paragraphs come after blank lines. Bullet points are okay too. Typically, a hyphen or asterisk is used for a bullet followed by a single space with a blank line in between. By conventions vary here. Use hanging indent. So I'm going to copy this pretty much in its entirety. And then I'll say um, what is it? Writing commit messages. We'll say right. Um, messages to start with a single line somewhere. Okay, like that. And then we'll give an example here. And I'll put it in a code block. So if we look at that, oh, there we go, into here. Or I'm gonna go like this actually. Let's just make this bigger. Then I'll just screenshot it. Copy image. Let's bring that back. Slightly. Okay. And then we'll just throw this image right here. There we go. Perfect. Nice. All right, let's keep on moving here. What you guys working on out there? Let me know what you guys are studying tonight. All right. If all your commit messages follow this model, things will be much easier for you and the developers with whom you collaborate. The Git project has well-informed commit messages. Try running git log no merges there to see what a nicely formatted project commit history looks like. Note, do we say not as we do? For the sake of brevity, many of the examples in this book do not have nicely formatted commit messages like this. Instead, we simply use the -m option to git commit. In short, do as we say, not as we do. Private small team. The simplest setup you're likely to encounter is a private project with one or two other developers. Private in this context means closed source, not accessible to the outside world. You and other developers have to push access to the repository. All have push access. In the environment, you can follow a workflow similar to what you might do when using Subversion or another centralized system. You still get the advantages of things like offline committing and vastly simpler branching and merging, but the workflows can be very similar, and the main difference is that the merge happened client side rather than on the server at commit time. Let's see what it might look like when two developers start to work together with a shared repository. The first developer, John, clones the repository, makes a change, and commits locally. The protocol messages have been replaced with the dot 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 in these examples to shorten them somewhat. So on John's machine, we git clone this repository, cloning simple git. You cd into it, you made some sort of change, and you commit uh, with automatic append and a message, or an add and a message remove invalid default value. The second developer, Jessica, does the same thing, clones the repository and commits a change. Git clone for Jessica, git host simple git.git, and then they go into the to do and they commit add reset task. Now Jessica pushes her work to the server, which works just fine. The last line of the output shows a useful return message from the push operation. The basic format is old ref dot 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 new ref from ref to ref, where old ref means old reference, new ref means new reference, from ref is the name of the local reference being pushed, and to ref is the name of the remote reference being updated. You'll see similar output like this below in the discussions, so having a basic idea of the meaning will help in understanding the various states of the repositories. More details are available in the documentation for git push. Continue with this example. Shortly afterwards, John makes some changes, commits them to his local repository, and tries to push them to the same server. So git error failed to push some references. John gets simple git rejected. In this case, John's push fails because of Jessica's earlier push of her changes. This is especially important to understand if you're used to Subversion, because you'll notice that the two developers didn't edit the same file. Although Subversion automatically does such a merge on the server if different files are edited, with Git you must first merge the commits locally. In other words, John must first fetch Jessica's upstream changes and merge them into his local repository before he's allowed to push. Okay, so he has to pull from Jessica's push and then merge it into his and then push. As a first step, John fetches Jessica's work. This only fetches Jessica's upstream work. It does not yet merge it into John's work. At this point, John's local repository looks something like this, where you have he pulled from this copy, origin master, got you, or this commit here. Now John can merge Jessica's work that he fetched into his own local work. Merge origin master, merge made by the recursive strategy to do plus one files change. As long as that local merge goes smoothly, John's updated history will now look like this, where it references the greatest ancestor. Gotcha. At this point, John might want to test his new code to make sure that none of Jessica's work affects any of his, and as long as everything seems fine, he can finally push the new merge change new work up to the server. In the end, John's commit history looks like this. In the meantime, Jessica has created a new topic branch called issue 54 and made 3 commits to that branch. So she hasn't fetched John's changes yet, so her commit history looks like this. She pulled this commit, made it branched out and made some issue changes, right? Suddenly, Jessica learns that John has pushed some new work to the server and she wants to take a look at it. She fetch all new content from the server that she does not have with git fetch from origin. That pulls down the work John has pushed up to in the meantime. Jessica's history now looks like this. Okay, so now we got John's work in there too. Jessica's history after fetching John's changes. Jessica thinks her topic branch is ready, but she wants to know what part of John's fetched work she has to merge into her work so that she can push. She runs git log to find out. Git log dash dash no merges issue 54 dot dot origin slash master. The issue 54 dot dot origin slash master syntax is a log filter that asks Git to display only those commits that are on the latter branch. In the case of origin slash master and that are not on the first branch, in this case, issue 54, we'll go over the syntax in detail in the commit ranges. From the above output, we can see that there is a single commit that John has made that Jessica has not merged into her local work. If she merges origin/master, that is the single commit message that will modify her local work. Now Jessica can merge her topic work into her master branch, merge John's work, origin/master, into her master branch, and then push back to the server again. First, having committed all of her work on issue 54 topic branch, Jessica switches back to her master branch in preparation for integrating all of this work. Jessica can merge either origin/master on issue 54 first. They're both upstream, so the order doesn't matter. The end snapshot would be identical no matter which order she chooses, only the history will be different. She chooses to merge the issue 54 branch first. No problems occur. As you can see, it was a simple and fast-forward merge. Jessica now completes her local merging process by merging John's earlier fetched work that is sitting in the origin master branch. Everything merges cleanly, and now Jessica's history looks like this. Jessica's history after merging John's changes. Now origin master is reachable from Jessica's master branch, right? So she should be able to successfully push John, assuming John hasn't pushed even more changes in the meantime. Each developer has committed a few times and merged each other's work successfully. That is one of the simplest workflows. You work for a while, generally in a topic branch, and merge that work into your master branch when it's ready to be integrated. When you want to share that work, you fetch and merge your master from origin master if it has changed, and finally push your master branch to the server. The general sequence is something like this. Private managed team. In the next scenario, you'll look at contributor roles in a larger private group. You'll learn how to work in an environment where small groups collaborate on features, after which those team-based contributions are integrated by another party. Let's say that John and Jessica are working together on one feature called this feature A, while Jessica and a third developer, Josie, are working on a second, say feature B. In this case, the company is using a type of integration manager workflow where the work of the individual groups is integrated by only a certain engineers, and the master branch of the main repo can be updated by only those engineers. In this scenario, all work is done in a team-based branches and pulled together by integrators later. Let's follow Jessica's workflow as she works on her two features, collaborating in parallel with two different developers in this environment. Assuming she already has her repository cloned, she decides to work on feature A first. She creates a new branch on the feature and does some work on there. So on Jessica's machine, she checks out and branches feature A. Switch to new branch, feature A. She does some work in there and commits and adds a new message saying add limit to log function. At this point, she needs to share her work with John, so she pushes her feature A branch commits up to the server, right? She commits and then she pushes, so git push feature A. Jessica doesn't have a push access to the master branch, only integrators do, so she has to push to another branch in order to collaborate with John. Jessica emails John to tell him that she's pushed some work into a branch named Feature A and that he can look at it now. While she waits for feedback from John, Jessica decides to start working on Feature B with Josie. To begin, she starts a new feature branch, basing it off the server's master branch. So she fetch origin, checks out, makes a new branch called Feature B within origin master. Jessica now makes a couple of commits on the Feature B branch. Commit, commit. Jessica's repository now looks like this. All right, she made a feature, she pulled from master, feature A, made a commit, and pushed it back onto master. She then made another snapshot or branch from master for feature B, made two commits, and then pushed those back onto master. She's ready to push her work, but she gets an email from Josie that a branch with some initial feature B work on it was already pushed to the server as feature BEE branch. Jessica needs to merge those changes with her own branch before she can push her work to the server. Jessica first fetches Josie's changes with git fetch. So git fetch origin. It takes this feature BE that she needs now. Assuming Jessica is still on her checked out feature B branch, she can now merge Josie's work branch. So she merges origin feature B into her current feature B branch. At this point, Jessica wants to push all the merge feature B work back to the server, but she doesn't want to simply push her own feature B branch. Rather, since Josie has already started an upstream feature B branch, Jessica wants to push to that branch, which she does with git push uorigin feature B. This is called ref space. Okay, so we'll go here and call ref space. If I point to this to come back. Ref space. Everything you can do with them. Also notice what is ref space in Git. 1670. Oh, that is a terrible angle that I was laying at right there that whole time. Double chin city. That angle's so bad. Git ref space is an official common used term. Git term, you might be thinking of refs, which are core. Okay. This is short for set upstream, which configures a branch for easier pulling. Suddenly, Jessica gets an email from John, who tells her he pushed some changes to the feature A branch on which they are collaborating, and asks Jessica to take a look at them. Again, Jessica runs a simple git fetch to fetch all new content from the server, including, of course, John's latest work. Jessica can display the log of John's new work by comparing the contents of the newly fetched feature A branch with her local copy of the same branch. So she does git log feature A ..origin / feature A. If Jessica likes what she sees, she can merge John's new work into her local feature A branch with that. Finally, Jessica might want to make a couple minor changes to all that merged content, so she is free to make those changes, commit them to her local feature A branch, and push the end results back to the server. Jessica's commit history now looks something like this. Wow. Jessica's history after committing on a feature. At some point, Jessica, Josie, and John inform the integrators of the feature A and feature B branches of the server are ready for integration into the mainline. After the integrators merge those branches into the mainline, a fetch will bring down the new merge commit, making the history look like this. Many groups switch to Git because of this ability to have multiple teams working in parallel, merging the different lines of work late in process. The ability of some smaller subgroups of a team to collaborate via remote branches without necessarily having to involve or impede the entire team is a huge benefit of Git. The sequence for the workflow you saw here is something like this. Forked public project. Contributing to public projects is a bit different. Forked public project. Contributing to public projects is a bit different because you don't have the permissions to directly update branches on the project. You have to get the work to the maintainers some other way. The first example describes contributing via forking on Git hosts that support easy forking. Many hosting sites support this, including GitHub, Bitbucket, Repo.org, CZ, and others. And many project maintainers expect this style of contribution. The next section deals with projects that prefer to accept contributed patches via email. First, you'll probably want to clone the main repository, create a topic branch for the patch or patch series you're planning to contribute, and do your work there. The sequence may look basically like this. You clone, you CD, you check out, and you branch, you work, you commit, you work, you commit. You may want to use rebase-i to squash your work down to a single commit, or rearrange the work in the commits to noose to make the patch easier for the maintainer to review. When your branch work is finished and you're ready to contribute it back to maintainers, go to the original project page and click the fork button, creating your own writable fork of the project. You then need to add the repository URL as a You then need to add this repository URL as a new remote of your local repository. In this example, let's call it my fork. You then need to push your new work to this repository. It's easy to push this topic to the topic branch you're working on to the fork repository rather than merging that work into your master branch and pushing that. The reason is that if your work isn't accepted or is cherry picked, you don't have to rewind your master branch. The git cherry pick operation is covered in more detail in rebase cherry pick workflows. If the maintainers merge, rebase, or cherry pick your work, you'll eventually get back via pulling from their repository anyhow. In any event, you can push your work with git push u my fork feature A. Once your work has been pushed to your fork of the repository, you need to notify the maintainers of the original project that they have work you'd like them to merge. This is often called a pull request, and you typically generate such a request and either via the website. GitHub has its own pull request mechanisms that we'll go over in GitHub, or you can run the git request pull command and email the subsequent output to the project maintainer manually. The git request pull command takes the rebase branch in which you want um, your topic branch pulled and the git repository URL you want them to pull from, and produces a summary of the changes you're asking to be pulled. For instance, if Jessica wants to send John a pull request and she's done 2 commits on the topic branch she pushed, she can do this: git request pull origin master my fork. The following changes since committed. Gotcha. This output can be sent to the maintainer. It tells them where the work was branched from, summarizes the commits, and identifies from where the new fork is to be pulled. On a project for which you're not the maintainer, it's generally easier to have a branch like master always track the origin/master and do work do work um, in the topic branches that can be easily discarded if they're rejected. Having work themes isolated into topic branches also makes it easier for you to rebase your work if the tip of the main repository has moved in the meantime and your commits no longer apply cleanly. For example, if you want to submit a second topic of work to the project, don't continue working on the topic branch you just pushed. Start over from the main repository's master branch. Gotcha. Now, each of your topics is contained within a silo similar to the patch queue that can rewrite, rebase, and modify without the topics interfering and interdepending on each other. Let's say the project maintainer has pulled in a bunch of other patches and tried your first branch, but it no longer cleanly merges. In the case, you can try to rebase that branch on top of origin/master, solving the conflicts for the maintainer, and then resubmitting your changes. The rewrites This rewrites your history to now look like the commit history after work feature A. Because you rebased your branch, you have to specify the -f to your push command in order to be able to replace the feature A branch on the server with a commit that isn't a descendant of it. An alternative would be to push this new work to a different branch on the server, perhaps called feature AV2. Now let's look at one more possible scenario. The maintainer has looked at work in your second branch and likes the concept, but would like you to change an implementation detail. You'll also take this opportunity to move the work to be based off the branch's current master branch. You start a new branch based on the current origin/master branch, squash the feature B changes there, resolve any conflicts, and make the implementation change, and then push that as a new branch. The squash option takes all of the work on the merge branch and squashes it into one change set, producing the repository state as if a real merge happened without actually making a merge commit. This means your feature commit will have one parent only and allows you to introduce all the changes from another branch and then make more changes before recording the new commit. Also, the no commit option can be useful to delay the merge commits in case the default merge process. At this point, you can notify the maintainer that you've made the request changes and then they can find your changes in the feature BV2 branch. How long is this goddamn section? Holy cow. This is ridiculous. Many projects have established procedures for accepting patches. You'll need to check the specific rules for each project because they will differ. Since there are several other older, larger projects which accept patches via a developer mailing list, we'll go over an example of that now. The workflow is similar to the previous use case. You can create a topic branch for each patch series you work on. The difference is how you submit them to the project. Instead of forking the project and pushing your own writable version, you generate email versions of each commit series and email them to the developer mailing list. Now you have two commits that you want to send to the mailing list. You use git format patch to generate the mbox formatted files, and you can email to the list. It turns each commit into an email message with the first line of the commit message as the subject and the rest of the message plus the patch that commit introduces as the body. The nice thing about this is that applying a patch from an email generated with format patch preserves all the commit information properly. Git format patch origin master. The format patch command prints out the names of the patch files it creates. The -m switch tells Git to look for renames. The file ends up looking like this. You can also edit these patch files to add more information from the email list that you don't want to show up in the commit message. If you add text between the -- line and the beginning of the patch, the git diff -- git line, the developers can read it, and that content is ignored by the patching process. To email this to a mailing list, you can either paste the file into your email program or paste it in via a command line program. Pasting the text often causes formatting issues, especially with smarter clients that don't preserve new lines or other white space appropriately. Luckily, Git provides a tool to help you send properly formatted patches via IMAP, which may be easier for you. We'll demonstrate how to send a patch via Gmail, which happens to be the email agent we know best. We can read detailed instructions for a number of mail programs at the end of the aforementioned documentation submitting patches file in Git source code. First, you need to set up the IMAP section in your Git config files. You can set the files separately with the series of Git config commands, and you can add them manually, something like this. If your IMAP server doesn't use SSL, the last two lines probably aren't necessary, and the host value will be IMAP instead of IMAPs. Okay. At this point, you should be able to go to your drafts folder, change to the field to the mailing list you're sending on the patch to, possibly CC the maintainer or person responsible for that, and send it off. You can also send the patches through the SMTP server as before. You can set each value separate with series of git config commands, and you can add them manually in the send email section of your git config file. After this is done, you can use git send email to send your patches. Then git spins up like this. Okay, whatever. All right. Gosh, that was ridiculous. Oh my goodness. I think this is the last one. Yeah. Okay, last one. Last one, you guys. Almost there. Okay. 5.3. Distributed Git. In addition to knowing how to contribute effectively to a project, you'll need to know how to maintain one. This can consist of accepting and applying patches generated via format patch and email to you. You integrate changes in remote branches or for repositories you've added as remotes to your project. Whether you maintain a canonical repository or want to help by verifying or approving patches, you need to know how to accept work in a way that is clear for other contributors and sustainable by you over the long run. Working in topic branches. When you're thinking of integrating new work, it's generally a good idea to try out a topic branch, a temporary branch specifically. Okay, so we'll say topic branch is a temporary branch specifically made to try out a new work. This way, it's easier to tweak a patch individually and leave it if it's not working until you have time to come back to it. If you create a simple branch name based on the theme of the work you're going to try, such as Ruby client or something similarly descriptive, you can easily remember it if you have to abandon it for a while and come back later. The maintainer of the Git project tends to namespace these branches as well. such as sc/ruby_client, where sc is short for the person who contributed the work. You'll remember, you can create the branch based off your master branch like this. Or if you want to also switch to it immediately, you can use the checkout branch. Now you're ready to add the contributed work that you received into this topic branch and determine if you want to merge it into your long-term branches. After you receive a patch over email that you need to integrate into your project, you need to apply the patch to your topic branch to evaluate it. There are two ways to apply an email patch with git apply or git am. Applying a patch with apply. If you receive the patch from someone who generated it with git diff or some variation of the Unix diff command, which is not recommended, see the next section, you can apply it with the git apply command. Assuming you save the patch, you can apply this patch like this. This modifies the files in your working directory. It's almost identical to running a patch-p1 command to apply the patch, although it's more paranoid and accepts fewer fuzzy matches than patch. It also handles file adds, deletions, deletes, and renames if they're described in the git diff format, which patch won't do. Finally, git apply is an apply all or abort all model. Abort all model. Models where either everything is applied or nothing is, whereas patch can partially apply patch files, leaving your working directory in a weird state. Git apply is overall much more conservative than patch. It won't create a commit for you after running it. You must stage and commit the changes introduced manually. You can also use git apply to see if a patch applies cleanly before you try applying it. You can run git apply -- check with a patch. Git apply check, error patch failed. If there is no output, then the patch should apply cleanly. This command also exits with a non-zero status if the check fails, so you can use it in scripts if you want. If the contributor is a Git user and was good enough to use the format patch command to generate their patch, then your job is easier because the patch contains author information and a commit message for you. If you can, encourage your contributors to use the format patch instead of diff to generate patches for you. You should only have to use git apply for legacy patches and things like that. To apply a patch generated by format patch, you can use the git am. The command is named am as it is used to apply a series of patches from a mailbox. Technically, git am is built to read an mbox file, which is a simple plain text format for storing one or more email messages in one text file. It's something like this. This is the beginning of the output of the git format patch command that you saw in the previous section. It also represents a valid mbox email format. If someone has emailed you the patch properly using git send email and you download that into an mbox format, you can point git am to that mbox file and it will start applying all the patches it sees. If you run a mail client, you can save several emails out in mbox format. You can save entire patch series into a file, and you can use git am to apply them at one time. However, if someone uploads a patch file generated via git format patch to a ticketing system or something similar, you can save that file locally and pass that file passed on your disk to git am to apply it. You can see that if it applied cleanly and automatically create a new commit for you, the author information is taken from the emails from and date headers, and the message of the commit is taken from the subject and body before the patch of the email. For example, if the patch was applied to the mbox example above, the commit generated would look something like this. The commit information indicates the person who applied the patch and the time it was applied. The author information is the individual who originally created the patch and when it was originally created. But it's possible the patch won't apply cleanly. Perhaps your main branch has diverged too far from the branch the patch was built from, or the patch depends on another patch and you haven't applied yet. In that case, the git am process will fail and ask you what you want to do. This command puts conflict markers in any files it has issues with, much like a conflicted merge or rebase operation. You solve this issue much the same way. Edit the file to resolve the conflict, stage the new file, and then run git am resolved to continue to the next patch. If you want Git to try to be a bit more intelligently to try a bit more intelligently to resolve the conflict, you can pass a -3 option to it, which makes git attempt three-way merge. This option isn't on by default because it doesn't work if the commit the patch says it was based on isn't in your repository. If you do have that commit the patch was based on a public, the three option is generally much smarter about applying a conflicting patch. In the case without the three option, the patch would have been considered as a conflict. Since the three option was used, the patch applied cleanly. If you're applying a number of patches from a mail mbox, you can also run the am command in interactive mode, which stops it at each patch to find it finds and asks you if you want to apply it. This is nice if you have a number of patches saved because it can view the patch first if you don't remember what it is or not apply the patches if you've already done so. When all the patches for your topic are applied and committed into your branch, you can choose whether and how to integrate them into a longer running branch. If your contribution came from a Git user who set up their own repository, push a number of changes into it, and then sent you the URL to the repository and the name of the remote branch that the changes are in, you can add them as a remote and do merges locally. For instance, if Jessica sends you an email saying that she has a new great feature in the Ruby client branch for her repository, you can test it by adding the remote and checking out that branch locally. If she emails you again later with another branch containing another great feature, you can directly fetch and check out because you already have the remote set up. This is almost this is most useful if you're working out with a person consistently. If someone only has a single patch to contribute once in a while, then accepting over email may be less time consuming than requiring everyone to run their own server and having to continually add and remove remotes to get few patches. You're also unlikely to want to have hundreds of remotes, for someone who contribute only a few patches or two. However, scripts and hosted services make this easier. It depends largely on how you develop your own and how your contributors develop. The other advantages of this approach is that you get the history of the commits as well. Although you have legitimate merge issues, you know that where in your history their work is based, a proper three-way merge is the default rather than having to apply a 3 and hope the patch is generated off a public commit to which you have access. If you aren't working with a person consistently but still want to pull from them in the same way, you can provide the URL of the remote repository with the git pull command. This does a one-time pull and doesn't save the URL as a remote reference. Now you have a single topic branch that contains contributed work. At this point, you can determine what you'd like to do with it. This section revisits a couple of commands so you can see how you can use them to review exactly what you'll be introducing if you merge this into your main branch. It's often helpful to get a review of all commits that you are in this branch but that aren't in your master branch. You can exclude commits in the master branch by adding the not option before the branch name. This does the same thing as the master contrib format that we used earlier. For example, if your contributor sends you two patches and you create a branch called contrib and apply those patches there, you can run this. To see what changes each commit introduces, remember that you can pass the P option to the git log and it will append the diff introduced to each commit. To see a full diff of what would happen if you were to merge the topic branch with another branch, you may have to use a weird trick to get the correct results. This command gives you a diff, but it may be misleading. If your master branch has moved forward since you created the topic branch from it, then you will get a seemingly strange result. This happens when Git directly compares the snapshots of the last commit of the topic branch you're on and the snapshots of the last commit of the master branch. For example, if you added a line in the file on the master branch, a direct comparison of the snapshots will look like the topic branch is going to remove that line. If master is a direct ancestor of your topic branch, this isn't a problem, but if the two histories have diverged, the diff will look like you're adding all new stuff in your topic branch and removing everything unique to master branch. When you're really wanting to see the changes added to the topic branch, the work you'll introduce if you merge this with master branch. You do this by having Git compare the last commit on your topic branch with the first common ancestor it has with the master branch. Technically, you do this by explicitly figuring out the common ancestor and running your diff on it. More concisely, this. However, Neither of those is particularly convenient, so Git provides another shorthand for doing the same thing, the triple dot syntax. In the context of the git diff command, you can put three periods after another branch to get a diff between the last commits of the branch you're on and its common ancestor with the current other branch. This command shows you only the work your current topic branch has introduced since its common ancestor with master. It, that is a very useful syntax to remember. When all the work in your topic branch is ready to be integrated into a more mainline branch, the question is how to do it. Furthermore, what overall workflows do you want to use to maintain your project and how you'll have a number of choices, so we'll cover a few of them. One basic workflow is to simply merge all that work directly into your master branch. In this scenario, you have a master branch that contains basically stable code. When you have a work in a topic branch that you think you've completed or work that someone else has contributed and you verified and merged into your master branch, delete that just merged topic branch and repeat. For instance, if we have a repository with work in two branches named Ruby client and PHP client that looks like history with several topic branches, we can merge Ruby client followed by PHP client. Your history will end up looking like this after topic branch merge. That is probably the simplest workflow, but can possibly be problematic if you're dealing with larger or more stable projects where you want to really be careful about what you introduce. If you have more important projects, you might want to use a two-phase merge cycle. In this scenario, you have a long running branches master and develop, in which you determine that master is updated only when very stable release is cut and all new code is integrated into the develop branch. You regularly push both of those branches to the public repository each time you have a new topic branch to merge in. You merge into develop. I got no idea what it's talking about here. This way, when people clone your project's repository, they can either check out master to build the latest stable version and keep up to date on that easily, or they can check out develop, which is the more cutting edge content. You can also extend this concept by having an integrate branch where all the work is merged together. Then the code base on that branch is stable and passes tests. You merge it into a develop branch, and when that has proven itself stable, you fast forward your master branch. All right, almost there. The Git project has four long-running The Git project has four long-running branches: master, next, scene, formerly pu, proposed updates, and new work and maint for maintenance backports. When new work is introduced by contributors, it's collected into the topic branches in the maintainers repository in a manner similar to what we described. At this point, the topics are evaluated to determine whether they're safe and ready for consumption and whether they need more work. If they're safe, they're merged into next, and that branch is pushed up so everyone can try the topics integrated together. If the topics still need work, they're merged into scene instead. When it's determined that they're totally stable, the topics are remerged into master. The next and scene branches are the rebuilt of the master. This means master almost always moves forward. The next is rebased occasionally, and scene is rebased even more often. When a topic branch has finally been merged into master, it's removed from the repository. The Git project also has a maint branch, which is forked off from the last release to provide backport patches in case maintenance release is required. Thus, when you clone the Git repository, you have four branches that can be checked out to evaluate the project in different stages of development, depending on how cutting edge you want to be or how you want to contribute. And the maintainer has a structured workflow to help them vet new contributions. The Git project's workflow is specialized. To clearly understand this, you could check out the Git Maintainer's Guide. Rebasing and cherry picking workflows. Other maintainers prefer to rebase or cherry pick contributed work on top of their master branch rather than merging it in to keep mostly linear history. When you have work on a topic branch and have determined that you want to integrate it, you move that branch and run the rebase command to rebuild the changes on top of your current master or develop and so on branch. If that works well, you can fast forward your master branch and you'll end up with a linear project history. The other way you can introduce work from your branch to another is to cherry pick it. A cherry pick in Git is like a rebase for a single commit. It takes the patch that was introduced in the commit and tries to reapply it on the branch you're currently on. This is useful if you have a number of commits on a topic branch and you want to integrate only one of them, or if you have one commit on a topic branch and you'd prefer to cherry pick it rather than run rebase. For example, suppose you have a project that looks like this. Hey Armando, thanks for the kind words, dude. Appreciate you stopping in. Thanks for joining me. If you want to pull commit E43A6 into your master branch, you can run git cherry pick E4386. So just that commit into it. This pulls the same changes introduced in E43A6, but you get a new commit SHA1 value because the date applied is different. Now your history looks like this. Now you can remove your topic branch and drop the commits you don't want to pull in. Rarere, what? R-E-R-E-R-E. If you're doing lots of merging rebasing, and you're maintaining a long-lived topic branch, Git has a feature called re that can help. Re stands for reuse record resolution. It's a way of shortcutting reuse recorded resolution. It's a very short-cutting manual conflict resolution. When re is enabled, Git will keep a secret pre and post images from successful merges, and if it notices that there's a conflict that looks exactly like the one we've already fixed, it just uses the fix from the last time without bothering you with it. This feature comes in two parts, a configuration setting and a command. The configuration setting is re.enable that is handy enough to put in your global config. Now whenever you do a merge that resolves conflicts, the resolution will be recorded in the cache in case you need it in the future. If you need to, you can interact with the re cache using the git re command. When it's invoked alone, Git checks the database and resolution and tries to find a match with a current merge conflict and resolves them. There are also subcommands to see what will be recorded to erase specific resolutions from the cache and to clear the entire cache. When you've decided to cut a release, you probably want to assign a tag so you can recreate that release at any point going forward. You can create a new tag as discussed in Git Basics. If you decide to assign the tag as the maintainer, the tagging may look something like this. If you do sign your tags, you may have the problem of distributing the public PGP key used to sign your tags. The maintainer of the Git project has solved this issue by including their public key as a blob to the repository, then adding a tag that points directly to that content. To do this, you can figure out which key you want by running the gpg list keys. Then you can directly import the key into the Git rebase by exporting it and piping it through the Git hash object, which writes a new blob with those contents in Git and gives you back the SHA1 of the blob. Now that you have contents of your key in Git, you can create a tag that points directly to it by specifying the new SHA1 value of the hash object command gave you. If you run git push tags, the maintainer tag will be shared with everyone. If anyone wants to verify a tag, they can directly import the PGP key by pulling the blob directly out of their database and importing it into CPG. They can use that key to verify all your signed tags. Also, if you include instructions in the tag message, running git show tag will give you the end user more specific instructions about the tag verification. Because Git doesn't have a monotonically increased numbers like v1, 2, 3, or the equivalent to go with each commit, if you want to have a human readable name to go with the commit, you can run git describe on the commit. In response, git describes a string consisting of the names of the most recent tag earlier in the commit, followed by the number of commits since the tag, followed by finally the partial SHA1 value of the commit being described. This way, you can export a snapshot or build and name it something understandable to people. In fact, if you build Git from source code clone from the Git repository, Git versions gives you something that looks like this. If you're describing a commit that you have directly tagged, it gives you simply the tag name. By default, the git describe command requires annotated tags. The tags created with the A or S flag. If you tag if you want to take advantage of the lightweight, non-annotated tags as well, add the tags option to the command. You can also use the string as the target of the git checkout or git show command, although it relies on the abbreviated sh81 value at the end, so it may not be valid forever. For instance, the Linux kernel recently jumped from 8 to 10 characters to ensure the sh81 object uniqueness, so older git describe outputs names were invalidated. Now you want to release a build. One of the things you want to do is create an archive of the latest snapshot of your code for those poor souls who don't use Git. The command to do so is git archive. If someone opens that tarball, they get the latest snapshot of your project under a project directory. You can also create a zip archive in much the same way, but by passing the format equals zip option to the git archive. You now have a nice tarball and a zip archive of your project release that you can upload to your website and to email to people. The short log. Almost there, guys. Last scene. It's time to email your mailing list of people who want to know what's happening in your project. Nice way of quickly getting a sort of change log of what has been added to your project since your last release is to email using the git short log command. It summarizes all the commits in the range you give it. For example, the following gives you a summary of all the commits since your last release if your release was named v1.0.1. You get a clean summary of all the commits since v.0.1, grouped by author that you can email to your list. Boom. All right. That was a lot longer than I thought it was going to be, to be honest. I thought that was going to be a lot shorter. How long have we been live for? Hour 30? Sheesh. All right, guys. That finished. That is it for chapter 4. Or chapter 5, I'm sorry, of Pro Git. Right. All right, let's go ahead and add this. All right. Sweet. All right, next up is chapter 6, you guys. Tomorrow we'll begin chapter 6 and getting into that. Let's see how long it is here. Chapter 6 is... it's pretty long. Whew. It's all right. Chapter 7 is pretty long too. Jeez, look at that. We might have to start breaking these up into multiple days. All right, you guys. That's going to be it for me this evening. I appreciate you guys joining me. Thank you so much for staying here and bearing with me as we read through Pro Git here. It's pretty confusing, honestly, in this back half of the book, just because I don't have a lot of experience actually using Git in project workflows with multiple contributors and things like that. So I'm sure as we get some more experience with actually using Git with multiple contributors and collaborating with people, we'll get some more familiarity with it. But yeah, it is pretty confusing right now. But I appreciate you guys joining me and bearing with me through these books. It's good introduction here, as we'll need to use Git in pretty much every workflow we get into if we have a job in this or whatnot. So thank you guys so much for joining me again tonight. We are back still in that different setup here at my girlfriend's place, just until we get back to our place. I'll be back in the normal setup tomorrow. We'll continue on with chapter 6 in Pro Git, and then we will also add in and start completing the settings features of the Small Business Manager. So, right, we completed all of the actual working mathematical features for tracking inventory expenses, transacting those inventory items, populating and generating income statements, and then finally resolving and completing a balance sheet for tracking these assets that we're loading in. So now we're going to create a settings page to allow the user to create custom filters or custom parameters that pertain to their business for these various drop down menus and such. So thank you guys so much for being here with me today. I'll see you guys tomorrow. Please join my Discord link down below where you can get access to all of my study resources as a general roadmap of my learning so far. I really appreciate you guys being here and joining me. Truly, it's great to have you here. And I'll see you guys tomorrow. Thanks for joining me. Bye, guys.